Good morning, children. Welcome back to ICAN Physics. Now, in this class, we are going to solve 2.6 from second lesson. Let's enjoy the class. Okay. So, three identical lamps, each having a resistance R, are connected to the battery of EMF as shown in the figure. Okay. When the switch is closed and open, what is the current, intensity, voltage and power in this circuit? Okay. So when the current flows through it, okay. So at this place, this is the important. Why? Because when it is open, then no current will flow through it. Then all the current is flowing directly. Okay. So when the switch S is open, so all the three bulbs are connected in series. So when it is connected in series, then automatically we can go for Rs equal to R1 plus R2 plus R3. Each has a resistance of R. So from that part we can say R1 equal to R2 equal to R3 equal to R. So finally we can get Rs equal to R plus R plus R. So finally we can get 3R is the resistance. Okay. So what they are asking, what is the current flowing through it? Okay. So when the resistors are connected in series, then the current will be same. Okay. So when the current flows in this. Okay. Do you get it now? Do you have any doubt? No doubt. So V equal to I into R. Here V. So V is given as psi of EMF. So psi equal to I. Then what about the resistance? Resistance in series. Then it becomes Rs. Now what is the value of Rs? 3R. So for instead of Rs, we can write I into 3R. So the multiplication 3R comes to this as division. So psi by 3R equal to I. So this is the current when the switch S is open. Okay. Do you get it now? Do you have any doubts? No doubt. Okay. The second case, when the switch S is closed. Okay. So when the switch is closed, due to sharp path of current, now the current will flow through the switch, then no current will flow through the third bulb. Okay. So what happened? So from the battery, the current flows through the first one, second one, and it flows through the switch and it comes. So only two bulbs are involved. So that it becomes Rs equal to R1 plus R2. Yes, sir. Then R1 equal to R2 equal to R. So Rs equal to R plus R. So it becomes 2R. So when it is connected in series, then the current will be same. Okay. So V equal to IR. How we can modify? Psi equal to I into Rs. Now what is the value of Rs? 2R. So I into 2R. The multiplication 2R comes to this as division. So sin by 2R equal to I. So this much of ampere when the S is closed. Okay. Do you get it now? Do you have any doubt? No doubt. So secondly, we are going to calculate the voltage. Okay. So when switch is open, so what about the voltage? When switch is closed, what is the voltage? Okay. So when the resistors are connected in series, the current will be same. But what happened? The potential drop across the first one is VA. Potential drop across the second one is VB. Potential drop across the third one is VC. So potential drop changes. Okay. So we know very well that V equal to I R. Now we can modify the formula. V A, that is voltage drop across the first one. Okay. So I, current is the same. So what is the resistance of the first one? So it can be taken as RA. Okay. So current will be same. Current will be same. So when S is open, what is the current? Psi by 3R. Okay. So psi by 3R into resistance of the first one. So first one, second one, and the third one having a equal resistance of R. So R getting cancelled. So psi by 3 is the voltage drop across the first one. Okay. Do you get it now? Do you have any doubts? No doubts. Then what about the voltage drop across the B? That is I into RB. Okay. So what is the value of I? Psi by 3R into RB is R getting cancelled. So psi by 3. So we see. So similarly, VC equal to I into RC. Then finally, once again, you can get psi by 3. Okay. Do you get it now? Do you have any doubts? No doubt. Okay. Then switch is closed. When the switch is closed, then no current will flows. When no current will flows, then there is no voltage drop, no current. So the voltage drop across the third one, VC, is 0. Okay. Then we can go for first case. So once again, V equal to IR. For the first one, VA equal to I into RA. So when S is closed, what is the current? Psi by 2R. So psi by 2R into R getting cancelled, psi by 2. Okay. Then we can go for second one, voltage drop across VB. So voltage drop across VB equal to I into RB. So I, psi by 2R into R getting cancelled, psi by 2. So when S is closed, the voltage drop across V is psi by 2. Okay. Do you get it now? Do you have any doubts? No doubts. So now the third one is power. So when switch is open, okay, when a switch is closed, then we are going to calculate the power. So what is the formula to calculate the power? Power equal to VI. Okay. So what is the power? Power across the first one is VA into I. Okay. So what is VA? That is psi by 3. Psi by 3. What is I? Psi by 3R. So psi into psi. So psi square. 3 into 3. 9R. Okay. So power across B is VB into I. So once again, psi by 3 into psi by 3R. So psi squared by 3 3s are 9R. Okay. Do you get it now? Okay. So power across the third one. Okay. So VC into I. Okay. So what is VC? That is psi by 3 into I. Psi by 3R. So psi into psi square. So 3 into 3, 9R. So this is the power. Okay. Then when switch is closed, then once again power equal to VI. Okay. So power through the first one is VA into I. So what is VA? VA. So voltage drop across the first one. Psi by 2 into current through the first is psi by 2R. So psi into psi square. So 2 2s are 4. 4R. So power across the second one is VB into I. So what is VB? Psi by 2 into I. Psi by 2R. Then psi into psi square. So psi square by 2 into 2, 4 R. Okay. Now, power across the third one, VC into current. So when it is closed, no current will flow. So the value of current is 0. So 0 into something 0, this also 0. So power is 0. Okay. Do you get it now? Do you have any doubts? No doubts. And we finally can go for intensity. Okay. So intensity. Okay. So for intensity, two cases. When S is open and S is closed. Okay. So when the switch is open, so current will flow through all the three. So all the three glow equally. Okay. Then when S is closed, when the switch is closed, no current will flow through the third one. So the bulb C will not glow. Will not glow. But the same current is flowing through the first one and the second one. So that A and B glow, and slowly it increases. Okay. Do you get it now? Do you have any doubts? No doubts.